Problem 3 on the way. Suppose the value of an investment is $75,000 after 60 months, and the value of the same investment is $83,280 after 84 months. So it looks like we've got 2 points. So I can already tell we're going to be needing to do something with point slope form. So I'm going to get ready for that. First off, we're asked to write an equation that models the value of this investment over time. It's important to remember that that money is always our y value. And so when we create our points, even though 60 was written second, it needs to go first because the y value has to be the money. So there's our first point, and our second point is going to be 84, 83 to 80. And so x1, y1, x2, y2. For this thing, we're going to need a slope. So we will do our formula, y2 minus y1 over x2 minus x1. And we've got 83 to 80 minus 75,000 over 84 minus 60. I'm going to give that right to Wolfram, everyone, and see what we come up with. $83,280 minus 75,000 over 84 minus 60. And we get a result of 345. So for this problem, our slope is going to be 345. Putting all that into slope-intercept or point slope form, everyone, we get y minus y1 equals m times x minus x1. Our y1 is 75,000. Our slope is 345. And our x1 is 60. Again, not a fan of that, so we're going to put it in here, get an alternate form to use instead. So 345 times x minus 60. And for alternate forms, there we go. Y equals 345x plus 54,300. So we got y equals 345x plus 54,300. So that's for part A. Again, both of those are an equation that represents this model, just that we prefer the second one because we can see a little bit more like the slope and the y-intercept. I can tell both of those from this equation. I cannot from this equation. So for part B, we do need to identify the slope and describe its meaning. So the slope is 345, meaning that every month the value of the investment is increasing by $345. Again, this is money this person is making for doing nothing because they have the money invested and the money is working for them. We'll talk more about these type of things as we move through this course, and it will be a major part of what we do in a couple sections, and it's super fun. So C is identify and interpret the y-intercept of this function. So our y-intercept, everyone, is 54,300. The y-intercept is 54,000, which represents the amount of money this person invested originally. So if we consider this problem a little bit, everyone, going from $54,300 that they put in to $83,000 after 84 months, which is 7 years, they have gained nearly $30,000 in 7 years for doing nothing just because they chose to invest their money into this thing. Pretty cool. So if the value of the investment continues to grow at this rate, how much will the investment be worth after 15 years? And so it's important to recognize that this is years and our function models months. So 15 years is the equivalent of 180 months. And so for part D, we need our function. So y equals 345x plus 54,300. And we are going at this for 15 years, which again is 180 months. So y is equal to 345 times 180 plus 54,300. And I think it's going to be sort of shocking when you see what ends up happening here, everyone. Again, it's important to remember that this person started with $54,300, just invested it, and then walked away. So we have y equals 345 times 180. They walked away and left this alone for 15 years. Let's see what the value of this investment is after this time. After this amount of time, the investment is worth $116,400. So basically, this person more than doubled their money for doing nothing over a period of 15 years. I'm going to pause and write my statement, and I will be right back. So put simply, everyone, after 15 years, $54,300 turned into $116,400. Again, this person did nothing, just let the money sit in the investment, and that, to me, is a big-time boom. Next, we have part E, which I believe asks, yes, how long will it take for the value of this investment to reach $1 million? And so in this instance, we are looking for time, so we're looking for X. And we want to know how long it will take for it to reach $1 million. I'm going to go ahead and write that down before I get ahead of myself. So we have our original equation, y equals 345x plus 54,300. We're wondering, under this model, how much time will it take $54,300 to turn into 1 million? And again, remember that this person is doing nothing. They just invested some money and walked away. We do get a fractional answer. Let's go ahead and hit approximate form so we get a decimal. And it looks like about 2,742 months. So I am going to divide that by 12 and see how many years that is. We get 228 years. So if the person were to leave this invested for 228 years, it would turn into $1 million. Probably not the fastest growing investment I have seen. But again, they put this money in there, they do nothing. They have $1 million after 228 years, a couple generations later. So it would take 229 years for this investment to reach a value of $1 million. And again, in later lessons and things, we will be talking about ways to make your money grow actually faster than this, and hopefully help you retire with a couple $1 million in the bank.